Okay, this one just starting. I'm gonna have to really edit it because I haven't done this problem before. It's gonna be sloppy. We're doing the curve is this. Ignore this at the top. Looking at this one at the bottom. What we have, and I started like 1 minute ago. All right, we got y equals square root of x. Y equals x squared. Revolved around the line x equals -2, and it's taken from x between 0 and 1. Alright, so that's here. Alright, what we were saying, and we're going to use, we can do it with the disk and the shell. We're going to do this with the disk method and the shell just to show the difference between the two. Alright, so I drew a little bar in here. This is like a sample shell, or the beginning of a shell. This is two-dimensional. But when we rotate this thing around the axis, right here is x equals -2, we get something like this. Alright, we get one shell. And then as we integrate all of these, we'll get a bunch of shells. And so if we can take the volume, if we can find the volume of one shell, or if we can, I guess we can find the surface area of one shell, and then we take it and integrate it over this region, this 0 to 1, and we'll find the area of all the shells. Alright, so yeah, I'm gonna have to make some notes on that. That didn't sound right, but I'll correct it later. So this is the one representative shell. We need to find this shell. We want to split it. Imagine this is a can of soup again. Alright, we're gonna take that can of soup, we're gonna split it right here down the middle. We're gonna open it up. So imagine we're like peeling this soup can apart. I'm opening it up. Alright, now the can of soup is made of metal. This thickness is the thickness of that metal. Okay? This is going to be, in this instance, dx. I'm going to start to write a little bigger. Alright? This right here is the circumference. It's kind of tough to see that. It's not even intuitive. You might want to pause it and then kind of take the paper and imagine if you had a can soup, you split it up like that. The circumference is this. This is the circumference, okay? This distance here. Alright, and that is equal to, what's the circumference of a circle? 2 pi r. Alright? And what's 2 pi r in this instance? What's r? R is the distance between the point of the axis of revolution and the shell. Okay, so in this instance, let me pause. I should pause it right here. Let me think about it for a second.